This video will demonstrate the calibration procedure used for calibrating general-purpose DC power supplies at Boise Calibration Service. The procedure is based on Air Force calibration procedures that are contained in the general-purpose equipment files. Inside the calibration procedure is a listing of DC power supplies and their specifications. In lieu of specifications that are contained in that particular calibration procedure, manufacturers' manuals and specifications will also be used. This is representative of a typical DC power supply that comes in for calibration at Boise Calibration Service. The parameters that are calibrated on this are the DC voltage output meter, the DC current meter, and then we'll also be checking for AC ripple when the power supply is loaded down. This is the representative of the power supplies. In calibrating it, we're going to be using the guild line current shunt, which is our current standard here at Boise Calibration Service. We'll also be loading the power supply down with the Biddle load resistor, and it's a variable resistor, and it moves back and forth, tapping off various resistances so that we can load the power supply down to as close to full rated output as we can. Additionally, we utilize the Hewlett-Packard 3458A digital multimeter. We utilize the DC voltage portion of that to calibrate the DC voltmeter part of power supplies, and then the meter is also used in conjunction with the current shunt to calculate the current. We also utilize this meter in the AC voltage function so that we can monitor ripple coming out of the power supply to ensure that the ripple meets the manufacturer's specification. The first thing that we're going to do is check the meter for accuracy on DC volts. So we'll go ahead and connect the digital multimeter to the power supply. We'll turn the power supply on with it in the meter selected in the volts position. We'll increase the output to full scale, which on this particular unit is 10 volts. Bring it up to 10 volts, like that. Looking at the indication on the HP 3458A digital multimeter, we see that it indicates 10.01 volts. That's within the specification of the HP power supply. The next procedure that we're going to do is check the calibration of the current meter on the HP power supply. So we'll turn the voltage down, turn the unit off, and we'll disconnect the digital multimeter from the power supply, and we'll move the test leads to the output of the guild line current shunt so that we can measure the voltage across the shunt on the digital multimeter. To calibrate the current portion, the current meter portion of the HP power supply, we go ahead and connect the current shunt and its load resistors using solid copper wire to the front panel output of the HP power supply. We go ahead and turn the power supply on, and then we adjust the voltage output so that it indicates 1 amp on the output meter. Since we know the value of the current shunt, we can use Ohm's law and derive the actual current flowing through the circuit. The indication on the HP DMM up here is the voltage drop across the current shunt. By utilizing Ohm's law equations, E equals IR, and variations of that, we're able to calculate what the actual current through this is. This particular reading of 99.0 millivolts, using the calculation, tells us that the current flowing through here is 1 amp. That's indicated on the HP power supply, and the power supply is correct. Now the next thing that we're going to do is change the digital multimeter over to the AC volts function. And since the power supply is fully loaded at this point to its maximum rated output, we have an indication of less than 600 microvolts AC ripple, and that also is within specification for the HP power supply. This concludes the calibration process for general purpose DC power supplies. What we've checked is the panel meter, either digital or analog depending on the meter, for voltage accuracy, and we've also checked the panel meter for current accuracy. We've also checked for AC ripple under load, and we've checked for AC ripple under no load conditions.